The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Our next speaker will be Sidney Freedman from PCI Chicago. He's the Director of Architectural Precast Services. Sid has been involved with architectural precast for over 40 years and definitely is the go-to resource if you're working on architectural precast. And he was the main author of Architectural Precast Panel, MNL 122, which is published by PCI. And he's published many other precast publications.
I am not John Earley. You're going to see a lot of, Deborah showed a lot of historic structures. You're going to see a lot of black and white pictures that I'm going to show. Most of them are from the 1930s. So they're all black and white. The National Historic Preservation Act of 1996 is an act based on the belief that the spirit and direction of the nation are founded and reflected in our historic heritage. However, some of the buildings shown in this presentation have probably been demolished while others are being repaired. The main one that I have a concern about is the David Taylor Model Basin, which I'll go into some detail on. That's in Carderock, Maryland. That's really the first building related to architectural precast. Between the years of 1913 and 1935, was the time when family enterprises using skilled artisans created a demand for cast stone, as Deborah showed, as a substitute for natural stone on building facings, sills, lintels, stairs, and architectural ornamentations. Unfortunately, the technology for this product was not fully developed, with many producers lacking both knowledge and skill. The product failed to withstand the normal attrition of weather and other durability issues. As a result, the industry at that time did not progress very far. We do have an active cast stone industry today because there were studies that were done by the National Bureau of Standards to determine what characteristics cast stone needed. During the late 1930s, a few architects cautiously began to use architectural concrete slabs for industrial and office buildings. The Earley studio did the slab work for these early buildings, notably the Squibb Laboratories in New Brunswick, New Jersey, and the Normandy Building in Washington, D.C., and these were done in 1938. However, John Earley and Basil Taylor, the founders of the Earley Studios, soon came to realize that the use of precast slabs could never gain much general use without more manufacturers entering into the precasting field. They hope to use the studio to become a center for the training and inspiration of other craftsmen with the vision, tenacity, and courage to carry on in a field whose potential seemed unlimited. This is John Earley and Basil Taylor, his partner. John Earley is on the left. Earley licensed other firms to use the Earley process and brought their craftsmen into his plant for training. This licensing and training policy was so effective that thin slabs became generally available throughout the East by 1939, and some of the new producers became formidable competitors of the Earley studio. As a matter of fact, ACI had a publication, which is obviously long obsolete, on thin precast slabs of 3 inches. This is the David W. Taylor Model Testing Basin in Carderock, Maryland. This was a pivotal development for the precast industry, which occurred in 1938 when the building was completed. The exterior surfaces of most of the buildings were faced with precast exposed aggregate reinforced concrete panels, which served as the outside form against which the structural concrete was cast. Oops, I keep on trying to push the top one. The walls of the office building are reinforced concrete, also cast against 2-inch forms of exposed aggregate concrete. Since this type of exposed aggregate concrete was originated and developed by John Earley, he was retained as an expert consultant for the work. However, the actual production of the panels for this project, totaling some 135,000 square feet, was undertaken by the Deckstone Company in New Haven, Connecticut, a cast stone manufacturer who had no previous experience in the production of this type of panel. Since the process was far from simple, consideration was required for the development of facilities and training performed by the Earley studios before a product was acceptable, quality was obtained. This is the model basin shop building. The panels for the shop building are shown in place, ready to receive concrete. Most of the slabs were either 8 or 10 feet high by 8 feet wide with a 2-inch thickness of concrete. Despite this unusual large surface area, it isn't large by today's standard. In those days, before we had the cranes, panels have gotten bigger and bigger within the precast industry as we have the capacity to lift large surfaces. But these panels weighed only 2,000 pounds and were able to be easily handled with ordinary stone setting derricks. This is the model basin drawings. The architectural panels on the main entrance tower of the model basin served as the forms for the cast-in-place concrete, eliminating the necessity for outer forms. Returns were also intricately cast with the facing. Working from the experience obtained on the model basin, Louis Falco of the Deckstone Company decided to make the exposed aggregate architectural slabs available for industrial purposes throughout the country. Falco filed for registration of the trademark Mosaic in December 1939, stating the name was in use since September of 1937. Since everyone was calling Earley Works the Earley Works slabs a concrete mosaic, it was an easy process to see how the name was developed. In Earley's mosaics, aggregate particles were substituted for the usual tesserae. The principal organization for precasters in those days was the Cast Stone Institute. Falco, who was a member of this group, invited 7 members of the Cast Stone Institute to join him in forming a new group. And this group was called the Mosaic Associates, and it was formed in 1940, and it later became the Mosaic Institute, as you can see here, in 1958. Disseminating the proper technical information was the #1 problem in the early days. Falco got around this one problem by sending a gentleman, Herman Frauenfelder, a man who was schooled in the in and outs of the Mosaic precasting, to the different member companies where he passed along the same proprietary information. By 1969, there were 22 members in the United States, Canada, and Japan. Along with the license fee came a geographic territory in which no other licensee would be issued for manufacture. This was not considered restraint of trade, as you were able to ship into any other territory. But the license required dissemination of technical information between the members and forbid the distribution to non-members. In fact, plants were not open for visits other than to Mosaic members. I'll tell you a quick aside. I gave a presentation at a Mosaic meeting, and as soon as I finished my presentation, they asked me to leave. So that I wouldn't get any of their secret information. But one of the producers said, well, I'll take you to my plant. I'll take you to see my plant. So this was in Richmond, Virginia, and the next day he drove up in his car, got in his car, and he took me to see his plant. Well, how did he take me to see it? He drove around the outside of the plant, and that's my plant. That's how things were kept. There was no sharing if you weren't a Mosaic member. Some of the trying to pry the basic information on the Mosaic formula was about as futile as trying to break into Fort Knox. The whole thing was kept carefully under wraps. Certain general facts were allowed to leak out. As you can see here, the thicknesses were typically 2 inches. The size ranged between 20 and 100 square feet. The reinforcement was 4 by 4, 3 and 3/8 inch galvanized. There were anchor loops that attached to the reinforcement, and you'll see a photograph a little later on. They were 1 inch wide by 3/32 thick galvanized strap iron hooked at 2-foot intervals. The facing and backing were 1 inch thick each with 5/8 inch aggregate. The compressor strength was 7,500 psi cube strength, and the absorption less than 5%. Today, the precast industry says you want to have less than 6%, but at that time they came up with 5, which is fairly close. I'm going to go through some of the production slides. Molds were typically constructed of wood, shellacked, and then lined with masonite, similar to what John Earley used. The masonite lining was given 2 coats of shellac, then coated with a solution consisting of 1/3 castor oil and 2/3 shellac. Shown here is a form for a 2-inch mosaic slab with a 10-inch return. The workman is filling the joints of the form with molding plaster to prevent leaks. Before casting, the forms were greased with a mixture consisting of 1 gallon of animal fat, which is tallow or lard oil, to 5 pounds of ground soapstone to prevent sticking of the casting to the mold. That was their release agent. With this treatment, forms could be reused approximately 60 times before relining was required. After the particular form had been built, it was coated with a retarder. The exact chemical composition of the surface retarder used was closely held information, as were all other technical information. An inspector is shown checking the form for the tolerances, the size and shape of the panel. The reinforcing mesh was temporarily placed in the forms to check for the proper fit. The batch of the facing mix is shown here discharged from the mixer. Note the stiffness of the mix. It's a little difficult to tell in some of these black and white photos. You can see how things were a little more primitive than they are today, just a little bit. After the facing mix was placed and vibrated with a plate vibrator, sometimes a grate vibrator, the reinforcement was placed in position on top of the vibrated facing, but not less than 3/4 inch back from the face of the panel. But Bob Armbruster, who's an expert on John Earley, is sitting there shaking his head when I'm mentioning some of the facts. This is what Earley did in his facility. The reinforcing mesh was held in the proper position in the middle thickness of the slab by small mounds of the backing mix under the mesh. It was important to keep the mesh, obviously, in the proper position to prevent corrosion of the steel. A batch of the backing mix is shown just discharged from the mixer. Note that this mix is less stiff than the facing mix. The backing mix is then placed and vibrated. Again, it's either a plate or a grate vibrator. Here, the workman is vibrating the slab in its final stages. The top of the side form is receiving vibration. This is done to help the mix go into place at the slab ends, and the returns were cast in a vertical position and were vibrated internally with a 1/2 inch rod pushed into the concrete. They didn't have the vibration processes that we have today. This is the stripping process. The panels were removed from the molds before the surface was thoroughly hardened, usually within 12 to 24 hours, depending on the air temperature. It was 12 to 14 hours when the temperature was 80 degrees Fahrenheit, and 18 to 24 hours when it was 50 degrees. The lower temperature was preferable to avoid excessive shrinkage resulting in hairline cracks. A typical slab is shown being lifted from the form. Note that there are Excelsior-filled sacks for the protection of the slab edges, and also that you can see there is the casting date, the mark number, and the piece number, all written on the back of the panel. The lifting was done slowly without jerking, as the panels were less than 18 hours old. As soon as the panel was removed from the mold, it was stacked on in a vertical position on a traveling easel and gone over with an electrically driven belt sander to remove excess mortar on the face, and then wire brush to remove the surface mortar and expose the aggregate in their true colors. Each panel was then checked for size, broken edges, sand pockets, and repaired if necessary. Repairs were made within 36 hours of casting. The panels were initially cured for 3 days, being thoroughly sprayed with water at least twice a day. On the 3rd day, a solution of 1 part of hydrochloric acid to 5 parts of water was applied and then brushed off using plenty of water. The proper degree of acid etching for uniform texture was then checked under a very strong light. At the end of this curing period, slabs were given a preliminary coating and subjected to a smearing operation to fill in small occasional voids, which occur in spite of the most careful casting. Then surface treating and hardening chemicals were incorporated on the face. Mosé had a manual with complete instructions covering brushing out and smearing in. The slabs then were subjected to further curing for 4 more days, wetting them twice daily. On the 7th day, they were given a final light acid etch wash of 1 part muriatic acid in 7 parts of water, except for spots that might need a stronger application to bring them to the desired texture. The panels were then ready for shipment. Mosé slabs are shown being placed on a trailer truck. The slabs were stored both in the yard and on the truck on wooden easels. To give you a little more information about some of the mix designs, the mixes were made on the slabs were rather unique. For aggregates used by the Mosé Associates, the Deckstone Company, well, at that time, they set up a crushing facility, their own crushing facility for the aggregates in Reading, Connecticut. And they had the only crushing and grading facilities in the United States which were devoted exclusively to the production of aggregates for architectural precast. The aggregates used in most Mosé projects had a hardness about 7 on the Mohs scale, approximately that of carbon steel. Colored granite, quartz, ceramic, or porcelain vitreous from all over the world were crushed and graded to the proper sizes to produce the facing portion of the mix. The crushing methods gave a cubical shape by using a hammer mill as the final crusher. Rounded or cubical particles not only assisted in obtaining a dense uniform texture, but their shape assured maximum embedment. The fines or sand also were for the same crushed materials. The sand was very clean and free of dust, as the dust might act as a pigment. The aggregates were shipped to all of the Mosé plants from that one location. These are some of the vitreous and ceramic aggregates that were used. You can see that they had some very bright or a little duller colors. The ceramic aggregates were made from high-grade clays and other ceramic raw materials by processes similar to those used in producing pottery and chinaware. The vitreous aggregates were made with materials and by methods similar to those used to produce porcelain frits or glass. While the colors of ceramic aggregates are bright and clear, they are characteristically soft in color. Vitreous aggregates are distinguished by their greater luster and brilliance than the ceramics. Certain colors can only be produced in the vitreous type of aggregate. The strength of the color of the concrete made with colored aggregates depend largely upon the extent which the exposed surface is composed of aggregate particles. A coverage of 80% is about the minimum which produces satisfactory results. Mosé mixes obtained a maximum of 85%. Those of you that may have been to the, what's that place called, the Baha'i Temple? The Baha'i Temple in Wilmette. If you go up and look very close at the area, you can see how dense Earley was able to make his mixes. That's what gave Earley's precast concrete it's really its beauty. And also, if you go to see Earley's homes out in Colesville Road, which hopefully when we have the convention in Washington will make the trip. The denseness of the mixes are something you don't see on too many projects today. Although when we're in Minneapolis, those of you that may have gone out and looked at the precast at Minneapolis, they were of the quality that Earley did. This is, to me, one of the critical factors in exposed aggregate concrete, gap grading. And I assume most of you know what gap grading is, which is where you leave out particular size particles and with intermediate sizes between the coarse and finer materials left out entirely. This provides a step or gap grading which was established in experiments conducted by Professor Robert McNeely, which was described in Engineering News Record November 27, 1915. Earley studied all the literature and patented in 1921. You know, Deborah talked about patents. You know, it would make an interesting research project to look at all the concrete patent. As I say, he patented the idea in 1921 of using the step of gap-graded aggregate to achieve uniformity and color control for exposed aggregate. This was an important contribution to the development of architectural concrete, since uniformity in the distribution of the aggregate in the surface and its exposure helps to prevent an uneven appearance. This is some of the typical mix proportions. The average mix proportions for the Mosaic and Earley panels were predominantly 1 part fines to 4 to 7 parts of 2 or more sizes of coarse aggregate. The aggregate cement ratio was approximately 4 parts to 1, while the water cement ratio in a very damp mix was as great as 0.53, or 6 gallons per sack of white or gray cement, except for returns where it was reduced slightly to prevent sand pockets. In many cases, color pigment was incorporated in the mixtures with colored aggregate rather than using pigments. It used the fines, very fine fines. The backup mixes were composed of 90 pounds of washed and screened concrete sand plus 306 pounds of crushed stone and were placed integrally with the face material. Once cast, the entire plastic mass of the panel was pneumatically vibrated a second time to ensure compaction of the material and draw the exposed back face, draw to the exposed back face any excess water. This was immediately evacuated by mechanical means or by use of hydroscopic materials so that the final concrete didn't end up as 0.53. It was probably somewhere hopefully around 0.4 or 0.45 or less. The one problem with all this all these projects that were done at this time was that air entrainment was not developed. So this is part of the problem in conservation of some of these projects. I received a call from the Navy about a year ago about the model basin that they want to do some repair work. As far as I know, they haven't done it yet. Surface texture, this is really what we're selling. Could speed it up. The surface texture was highly dependent on the size of the aggregate. You went down from 5/8 to possibly 3/8, depending on the distance that you were going to look at the panel. To prevent the mixtures from intermingling, they used either metal stripping, such as using terrazzo, thin strips of water composition, which were removed and the grooves filled in with a colored mortar, small ribs or fins on the face of the plaster molds, or they molded recesses in the face, and on the some of the depressions were just used to separate the panels. These are some of the early panels by, you can see the architecture isn't quite what we have today, and I'm really not sure if some of these buildings are still around. This is the Wire Corporation of America in New Haven, Connecticut, the Wilcox Building in Meridian, Connecticut, and this is, back when this is the Wilcox. You can see the name is on you can see considerable detail. This is a spandrel panel. You can just barely see there's a circle in the middle, and then there are some horizontal lines. This is the Ansonia manufacturing facility. The black aggregate was cast intricately, as well as the name in the spandrel panel, which was serving as a lintel. Deborah mentioned the Merritt Parkway. This is one of the projects that Deckstone did on the Clinton Avenue Bridge that they used. And let me just summarize. The creation of quality exposed aggregate architectural components is both an art and a science. For over 4 decades, Mosaic Institute members pooled their technical expertise and craftsmanship to produce a product whose singular beauty and quality enhance the value of outstanding buildings worldwide. The Mosaic members were not only pioneer producers, but industry leaders and innovators. Unfortunately, they were too wrapped up in their attempt to keep information within their organization, and they failed to see that the precast industry had acquired similar knowledge and techniques. Mosaic faded out of the picture in the mid-1980s, but the sharing of information by Earley Studio laid the foundation for the growth of the architectural precast concrete industry that we enjoy today. Just some of the quick projects that the Mosaic people did, they're not necessarily the old ones, but just an example of some of the quality projects.
Thank you, Sid.